Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at the theory of the observer pattern in Java. In the last tutorial we were looking at MVC, Model View Controller, and in fact we can't fully implement Model View Controller until we know how to implement the observer pattern, or at least that's often going to be the case, although perhaps not invariably. Now the observer pattern is something that you could write. Lots of programs don't use this pattern, and it's common in certain kinds of programs, and in particular the observer pattern, let's write this down, observer pattern is common in GUI programs, or in general, that's graphical user interface, or in general it's common in event-driven programming. And this is actually one of the patterns that gives beginners the most trouble, I find. It's the hardest to understand, partly because you need a good understanding of interfaces and references, and if you don't have that, certainly check out my free Java for Beginners course at caveofprogramming.com. And it's often used with anonymous classes as well, so it helps if you understand anonymous classes. And if you don't know all that stuff, then if you just enjoy watching videos about design patterns, then it's certainly going to help to see this video anyway. But you probably find that you need to know that stuff, references, interfaces, anonymous classes, to get the most out of the observer pattern. So the idea is here that in some kinds of programs we have objects which we call, in the terminology of the observer pattern, we have objects which we call the subject. Actually, I forgot to say, because this is such a tricky idea, what I'm going to do is I'm going to divide this into 3 tutorials, and in this tutorial we're just going to look at the theory. In the next tutorial I'm going to show you an example of this in practice, and then in the 3rd tutorial in this little sequence I'm going to show you how to implement this pattern yourself. And I am a big fan of the idea that it's not necessary to stress too much about the theory of this stuff. I just want to go through the theory here so that hopefully you'll get a basic idea of it, but don't stress about it, because typing stuff seems to be in programming like 80% of understanding, and if you type this a few times and you get it to work yourself, then you'll quickly start to have a feel for how this works. So this is just basically an overview to get you started. So we've got some objects here which we call the subject, and the idea is that things can happen in the subject at unpredictable times, so the rest of your program doesn't know when whatever it is going to happen in your subject. And a classic example here would be something connected with the user interface. For example, the subject could be an object that represents a button, so we don't know when a button's going to be clicked. It's up to the user. That's the whole point of a button, and that means that when a button's clicked, some code's going to be run within the subject, which is the object that creates and draws and represents the button, but we don't know when that will happen. Another example could be a timer, because a timer will sort of expire after some length of time, possibly at a regular interval, and the rest of your code outside of that timer object doesn't know when that's going to happen. It's the timer's responsibility to say when it's time to do something, and it has to somehow inform the rest of the code of that. And there are other examples. For example, sometimes you want to run some code on its own thread, so you want to call a method which will return immediately, and then your program will carry on its merry way. But the effect of calling that method will be to set something happening in the background, for example downloading a file, let's say, which will finish at an unpredictable time in the future. And again, something's going to happen in some object somewhere, which we call the subject, and we want some other code to be run in the rest of our program when the subject finishes what it's doing. So this doesn't apply if you're to kind of step-by-step programming. If you've just got a program and it's just like doing A and then B and then C. I've actually forgotten the technical term for this, but if you've just got a program that's doing one thing after another and it doesn't do the next step until it's completed the previous step, then you don't need this. You only need this when you've got code that's doing stuff all the time, and then there's stuff happening in the background that may do something at an unpredictable point, which then needs to affect the rest of your program. And a button is a great example to keep in mind. Because when we have like a user interface program, the user interface has to be able to update itself and to change the way it displays in response to the user clicking it and doing stuff with it. And so some kind of event management thread has to run all the time. The program has to be running constantly, in effect, in a user interface program. But at any moment the user might click a button, and then something must happen somewhere in the rest of the program in response to that. So the program's like doing its own thing, minding its own business, processing input and other stuff. It's doing whatever it's doing, and then someone's going to click the button and something will happen in the button object that it then has to respond to. That's event-driven programming, and this is where the observer pattern applies. So how can we actually do this in practice? What we want to do is we're going to have another object over here, and we call this object the observer. The observer. And we want to run some code in this object when something happens in the subject. So when a button's clicked or something, it will run some code in the observer, but it's only the subject that actually directly responds to the thing happening. Something happens in the subject that then must run code in the observer. And a kind of model to keep in mind, and the reason this is called the observer pattern, is, and this is also called the listener, by the way. We can also call this the listener. The model to keep in mind is, if you think about, let's say you've got a job and you've got a boss, and you kind of listen to your boss. So you're doing stuff, you're carrying out tasks, but you kind of keep one ear on your boss, so to speak. And if he tells you to do something, assuming you're in a good mood and you think it's appropriate to do it, then you do it. So in that case, you're a listener, you're an observer, and the boss is your subject. Something's going to happen in his brain, which you then have to respond to in amongst doing your other tasks. So it's kind of like you're listening or observing to this thing here, the subject, which in this analogy would be your boss. But of course, in a Java program, nothing's listening to anything, so we have to find some way of making this work. And if you're writing both of these objects yourself, you could pass a reference to the observer, a reference that points to the observer. You could pass this reference to the subject, and the subject could then just call a method in the observer. But that is bad practice very often, because you want to try not to have these two objects tightly coupled. Ideally, you don't want the subject to know that the observer exists, and yet you do want to be able to pass a reference to the observer, to the subject. Because if you think about it, you think about any user interface framework, for example Swing, which is built into Java, and there you have a class called JButton, and that represents and draws buttons. Now the people who implemented Swing have no idea what objects are going to exist in your program. How could they possibly know? You might have an object called Program Manager, which has a method called shutdown, and you might want the button, when it's clicked, to run the shutdown method in your program manager. But the people who wrote Swing have no idea that you were going to write that class. So how can you say to a button, here I want to run this code, please run this code that I'm going to give you? How can you say that? And in some languages you can pass function pointers or some kind of function reference, let's say, and this is some kind of pointer or reference to a block of code that you can then pass to a button, and a button will run that code. But in Java we don't have this. So in Java we don't have references to functions, unlike in JavaScript or C++ or something like that, where we do have them. In Java, the way we do it is if we want to run a block of code, a particular block of code, and we want to pass that block of code around, what we do is we create a object which implements an interface. So we have some interface, and this could be called, let's take an example. This could be called maybe let's call it event listener. It could be called event listener, and that interface specifies one method. So the whole point of this interface is to say that whatever implements it, the class that implements it, must have one particular method. Let's say it's called run. Now we make our subjects here, the buttons or whatever, we give them a method that enables us to pass in something that implements this interface, event listener. And what the subject then does is it says, okay, you pass me an object that implements event listener. I know that it must have a run method, therefore, because in this example here, which I've just made up, event listener, the whole point of it is to say that the implementing class has a run method. So the subject can then say, okay, I'll go to the run method, and when something happens, when I'm clicked or whatever, I will invoke the code in the run method and I will run it. And that's how this basically works. And there's another couple of little complications here, and if you're getting completely lost by now, don't worry too much, because we are going to look at this with some actual code. But one thing is, often a subject will maintain a list of observers or listeners. They mean the same thing, but there'll be a whole list of them, and it will notify each of them by running the code specified by some interface in each of them, one after the other, when the thing happens, whatever it is, the button's clicked or whatever. And also, often the subject needs to pass data to the observer, and it can do that simply by giving run an argument. And usually what we do is we make the argument of some particular type, which is some kind of, we call it an event. And we talk about the subject firing an event. So it fires an event, and that just means that it calls the method in the it calls the code in the method that the interface specifies, which the observer implements. So this is here, the subject's calling the method in this run code, and it passes it some object called an event or an event object, and that object has data in it, which is therefore passed to the observer. Now that probably sounds like a complete nightmare, but in the next tutorial we're going to look at a relatively simple example, or maybe one or two examples of this in practice, and then we're going to go on to see how we can implement this ourselves. So join me again next time, and until then, happy coding.